All right, so let's take a look at today's lesson. And this is the idea of what makes up most of our solar system. What is it that makes up most of our solar system? When people think of the solar system, they think of the sun, planets, moons, comets, and other objects. Actually, the solar system is mostly empty space. What? The biggest object in the solar system is the sun. The diameter of the sun, 1.4 million kilometers. In comparison to about 58 million kilometers of empty space, separate the sun from its closest planet, Mercury. That's a big number to think about. Well, let's go a little further. The whole solar system takes up a vast area of space, about 9 billion kilometers in diameter. Remember, diameter is if we have a circle, diameter is all the way across. That's over 6,000 times wider than the sun. It would take 6,000 suns side by side to go across our solar system. This evidence shows that even the sun is tiny compared to the empty space in the solar system. Holy cow. 99% of the solar system is what? What would you write down there? I'll give you a second to write something down or think about what it is. Answer that question in your head if you can. Did you put empty space? Because that's what it is. Most of the solar system is empty space. Holy cow. Remember that matter, M-A-T-T-E-R, is stuff. Anything that has mass, takes up space, we say is matter. If there's nothing there, we call it space. But if something's there, we call it matter. So see, you do matter. Haha, Mr. Jensen, that's funny. But take a look at this part right here. The diagram shows the relative size of the sun compared to the entire solar system. Here it is here. If we were to take this square, a 1 by inch square, and set it down on the 50-yard line of a football field, that would be like putting the sun in the middle of our solar system, and the football field, side to side, would be our solar system. You go, whoa, that's weird. I know. That's the biggest object right there. Would be that little tiny square in the middle of a football field. And then you go, oh, okay. So from end zone to end zone, yep. And then you'd have to extend it as a square or circular, kind of in a sense. That would be the center. And then little tiny specks would be next to it. Wow. So mostly just empty space. All the other objects in the solar system fill up even less of this empty space. Imagine gathering all 8 planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, and all their moons, plus all the asteroids, comets, and other objects in the solar system. All together, they would add up to an object smaller than the sun. Compared to all the empty space in our solar system, the objects in it are very small. Empty space makes up most of our solar system. Here's a picture of the sun right here as a square. Jupiter's right here. Saturn. Everything else gets smaller. You can't even barely see the square for the Earth. Everything together besides the sun would be smaller than the sun. Sun's the biggest object. Sun's not even that big. It's mostly just empty space. Okay, Mr. Jensen, you're freaking me out. As Apollo 13 and all the Apollo missions were heading towards the moon, you're telling me they were just traveling through empty space? There was nothing there? Yeah, they could have set up a lawn chair on top of their space rocket, sat down in it, no problem going 24,000 miles an hour because you're going through nothing. Well, that's freaky. Well, what about gravity? How does this work? Well, remember that your mass is everything that makes you up. That's your mass. It's what makes you up. Well, that thing's massive. Meaning there's a lot of stuff making that thing up. Your weight is just you or your stuff, everything that you are made of, being pulled by gravity. That's what your weight is, being pulled by your gravity. So if I take my weight on Earth and I put my weight down here, it's 252 pounds, that's what I am. I can multiply it by gravity and I can get this thing to work. Check this out. Earth, I weigh 252 pounds, so I put 252 on every single line because that doesn't change. That's my Earth's weight all the way down. And on Earth, I'm 1 times that. Anytime you take a number times it by 1, it's the same number, 252. But the gravity is less on the moon. So I take my weight on Earth, 252, and I multiply it by the gravity of the moon, which is about 0.17 the gravity of Earth. 42.84. My weight would be 42.84 pounds. I'd be about 43 pounds on the moon. I could jump around for days. I'd be like the size of a toddler as far as the weight goes, but my mass would be the same. Remember, your mass doesn't change. What makes you up stays the same. So Mr. Jensen doesn't look any different on the moon. He's still the same body, but the moon is smaller, the gravity is less, so it's pulling down on him less. So he would weigh less. What about Jupiter? Jupiter's huge. Take my weight, 252 pounds on Earth, multiply it by the gravity of Jupiter, 2.87. 2.87. Jensen, if you stepped out on Jupiter, 723 pounds. Holy cow, dude. That would be my 700-pound life. I would not be very mobile on Jupiter. Jupiter's massive. And the more mass, the greater the gravitational pull. So I would feel Jupiter pulling me down super hard if I was on the face of it. And it would make me feel like, well, I would weigh 723 pounds. Whoa. That's crazy. What about the sun? If I could stand on the surface of the sun, 252 pounds times the sun, 27.1. Jensen, you'd be flat on your face. You'd weigh 6,829 pounds on the sun. Dude, you're not even going to be able to stand up, Jensen. It's too difficult. Yeah, true that. True that. There we are. That is how you calculate that. So in your booklet, now you can calculate using your weight, not my weight, unless you feel uncomfortable, but use your weight, whatever your weight is. This is my weight. Now use your weight, multiply it by the gravity of each planet, and find out how much you would weigh on different places in the solar system. Give it a shot.